Hi there, this is Shaman here. In this video, I'm going to teach you relative atomic. Hi there, this is Shaman here. In this video, I'm going to teach you relative atomic mass and relative formula mass. Alright, what's the difference between relative atomic mass and relative formula mass? I'll explain details about and I'll give you example. Alright, so let's get started. So what is relative formula mass or relative atomic mass? It's the mean relative mass of the atoms of the different isotopes in an element. It's the number of times heavier an atom is and compared to 1/12 of a carbon-12 atom. So it's also equal to the number of protons and neutrons in the atom. All right, now I'm going to give you example of relative mass of oxygen. So can be found next to the chemical symbol on the periodic table. Where is that? So that is the periodic table. So it's 16. Okay, if you see that, if you check the periodic table, then you can get that this is 16. So question 1, using a periodic table, find the relative atomic masses of the following elements: sodium, lithium, and helium. So how will get that? Easy. Using a periodic table, find the relative atomic masses of the following elements: sodium 22.99, lithium 6.941, and helium 4.003. What is relative formula mass? Well, relative formula mass is the sum of the relative atomic mass of the atoms in the chemical formula. Or what is So the relative formula mass of water, the calculation. There are 2 hydrogen atoms and 1 oxygen atom in a molecule of water. So we'll just multiply and add together. That is 18.016. Calculate the relative formula mass of ammonia, that is nitrogen and hydrogen. Relative formula mass of ammonia. So there is 1 atom of nitrogen and 3 atoms of hydrogen in a molecules of ammonia. So here is a 3 atoms of hydrogen. So we know the hydrogen here is a 1.008 times 3. So we'll add together, then we'll get that. All right. All right, guys. Now I'm going to talk about relative formula mass of glucose. So there. All right, guys, there are 6 atoms of carbon and 12 atoms of hydrogen and 6 atoms of oxygen in a molecule of glucose. So we need to multiply like a carbon. Here's a 6 carbon, 12 hydrogen, and 6 oxygen. So we'll multiply and add together, and then we'll get that. There are 6. All right, guys, thank you so much, and bye. See you later.